Hi, Woodstock students. Sorry to be missing you again this Friday. I'm very sorry about this week. It's been a very tough week health-wise, and I'm out for some other reasons today. I'll see you next week. You're going to be doing a simulation today about forces and motion, and you've got a handout, and I want to lead you through, what's going to happen when you access this phet from the University of Colorado. Okay, when you get to the front page of it, it's going to look like this. There's a little stick figure and a crate that you can push back and forth. But if you look at the settings for activity A, the settings will tell you like how to set it up so that you get what I want you to be looking at. So there are a number of tabs up at the top, and it says to select the Force Graphs tab. So we will, and that brings up a number of things here. Okay, I'm going to close some things for a second just so you see what's happening. And if you go to the other settings, it says, well, you should be choosing ice. So in terms of friction, let's have ice, so there's no friction, okay? In terms of the object, you have all kinds of possibilities here, but we're gonna choose the textbook, and then in terms of graphs, you're going to want a force graph, which has right here, and an acceleration graph. And if you pick those two things, you'll be in a good place to see what's going on. Okay, I'm going to clear down here. I'm going to clear the graphs so that they're starting from 0, and I'm going to hit the play button, and you'll notice that the graphs start to record your force and acceleration. Now it looks like this stick figure is in the wrong place. Is going to start pushing against the wall, but you don't have to worry about that at all. Don't worry about his position. Just grab the textbook and slide, okay? And that will create a force. Now the event is over. I'm just going to pause it here, and you see that my force is off the scale, so I can zoom in. Oops, sorry, I went the wrong way. I can change the scale until I see, there we go, until I see a relatively consistent force right there. So I might have to estimate that. That might be maybe 250 newtons or something like that. And I've got a similar issue here with acceleration. I can change the scale a little bit, and I get an acceleration of just less than 24. So estimating those things is going to be helpful and important, and I'm going to want you to do that. Okay, so whenever you're ready to do your next trial, you can just hit the clear button to clear off the graphs. You can hit the record button to get the graphs going, and then again, just drag the textbook with your device, with your mouse, and slide it, and then start to take a good look at the forces and the accelerations. You can ignore the minus signs or include them. It doesn't really matter. I think it might be easiest to just think of everything as being positive, and taking a good look at the force you applied and the resulting acceleration, and putting that in your first table to try to come up with a relationship between those things. Okay, I want to show you one more thing, and that is going to come up in Activity B. In Activity B, you're asked to choose the wooden surface so there is some friction. Okay, everything else is the same. And if I clear my graphs, you see it's going again. Let me just stop it for a second. If I clear my graphs, I'm going to do the same thing I've done before. I'm going to grab the textbook and drag it to the right with a certain amount of force. But I've got to be recording when I do that. Okay. So I'll go ahead and do that. Okay, I've got a certain force. Okay. And you may have missed it, but over here in the left-hand side, there's a little list of forces, including the frictional force. So watch what happens when I drag it back the other way. Look at the number right over here. Don't pay attention to the drag. Like, just get that. There it is, 19.6 it said. Okay, let's try it one more time. Okay, 19.6 was the frictional force, and there are some other values that pop up when it crashes into the wall and so forth, but that was the frictional force that the textbook has on that wooden surface. Okay, so you want to be recording that, and the other pieces will be recorded on your graphs, so you don't have to be looking at them consistently. Okay, so you want to try throughout this investigation. You want to try a number of different forces and see what comes up, and then try to derive relationships from your data. Okay, hope you do well, and I'll look forward to chatting with you about this next week. Take care. Bye.